uh, there in Boise and also online, and especially to Farnaz Nazari for setting this up. So today we're talking about increasing life cycle energy efficiency for buildings. We often talk about operational energy of buildings at BSUG. Today we're going to talk about the efficiency of making the materials that go into the buildings, which have a really big impact, especially in a place like Idaho where we do a lot of manufacturing, a lot of production of bio-based materials as well, timber and things like that, where LCA has a really big influence. So, but I'll let the main speaker get to that. So let me just run through some of our introductions. For those that don't know us, we're a research branch of the University of Idaho's College of Art and Architecture, a small research team of faculty and students and research scientists, all focused on how buildings use energy. So we're here for education, for outreach, and technical support, which is thankfully funded a lot through Idaho Power, including this lecture series. So thank you to Idaho Power, who's providing lunch for those that are in person, and also for sponsoring this lecture series. So some of our other resources that are available to Idaho Power customers is our Energy Resource Library. We have close to 900 different tools, all for building energy assessment. And we're about to purchase two new ones that are ultrasonic and sonic leak detectors for compressed air. So we're about to get a Fluke II900 camera. So it's about a $23,000 camera. So if you're doing any commissioning looking for gas or compressed air leaks, you'll be able to check that out for free rather than dropping 25,000. So that's great news. We're going to be doing some different experiments with it. So you'll have to wait until the end of the year to start renting it. But afterwards, it'll be free to you. And that's available on our website. Just go to idlboise.com and you can fill out application. We have, of course, our building simulation users group, meeting 6 times a year, bringing in great speakers like Vaclav. And then for those in Idaho Power Service Territory, we have our Lunch and Learn program where we come to your firm, provide lunch and continuing education. But we also have a couple of hybrid lectures that we're doing where it'll be much like this BSUG available in person as well as online. So we had high performance classrooms last month. And then coming up on August 22nd, Dylan will be speaking about luminaire level lighting controls. And then on November 7th, Farnaz will be speaking on existing building commissioning. So check those out. Come for lunch or attend online from your desk. It'll be free for you to do that. We also have our technical design assistance program. So if you have a new technology that you have interest in, or a new building design or a new simulation tool that you want to try out, but you need some technical support with it, the IDL can help with that. We're not trying to be our own consulting firm, rather that we're trying to consult with you so that you gain that expertise, kind of teaching you to fish, to give your firm that capability moving forward. So if it's less than $2,000 worth of our time, you don't even have to fill out any paperwork. It's just free. We're a free help desk. You can call us or email us. Just go to our website, IDL Boise, look for design support services, and you'll find that there. If it's up to $4,000 worth of our time, we'll submit a simple scope of work to Idaho Power for review. They will look it over and then get back to us within the week of whether we're authorized to work on it or not. And basically, if it's about energy efficiency and in the commercial realm and potentially a large multifamily project or mixed use, we can help with that. And then if it's more than $4,000 worth of our time, then there's a cost share. 75% of that is covered by Idaho Power, and then 25% would go to the owner, just to show that you have some skin in the game, that you're really invested in us doing a really in-depth analysis or energy model or simulation. And then Idaho Power has a couple of their own programs, large programs independent of Integrated Design Lab, their new construction, major renovation. So both prescriptive as well as custom, and that's available on their website. And then provide professional assistance incentives for third-party architects and engineers. Same for retrofits. They also have a flex peak demand response program. Doing that a lot with irrigators, but also available to very large commercial and sometimes industrial customers there. There's also the professional assistance that is available to help architects and engineers, the designers in the room and online, to fill out some of that paperwork so that you can get that incentive. So most important thing to remember is just get those pre-applications in. If you've got a new project and you're going to be doing something innovative in terms of energy, going above and beyond code, fill out a pre-application form. It's pretty simple. Cherie is there in the room. She can speak to it more if needed. But make sure you fill that out at the very beginning, even before you know all of the details. That will allow them to actually provide the incentive. It's tough to provide that after the fact. All right, but that's enough from me. I want to turn it over to Vaclav. So let me stop sharing and go ahead and share your screen. We're very pleased to have Vaclav Hasik with us today. He earned his bachelor's in mechanical engineering from Elizabethtown College and his doctorate in civil and environmental engineering from University of Pittsburgh. He's a program director at Building Transparency, which is a nonprofit program organization behind the EC3 tool. And he'll be talking about that a little bit along with tallyLCA and tallyCAT. He's worked as a sustainability analyst, LCA expert, a researcher at University of Pittsburgh, and we're just very, very pleased to have his expertise and his willingness to share that with us today. So thank you very much, Vaclav. And if you've got others on your team that you want to introduce, feel free, but I'll let you take it away.
Great, thanks for the intro. It's just going to be me today, but yeah, thank you for the great intro. My former advisor, actually, for my PhD program is right here. So just wanted to say hi to her as well. Hi, Melissa. But otherwise, I'm very happy to be here and kind of share, what I've learned over the years about this topic, and also obviously show you some of the tools that we provide as a nonprofit organization trying to help people address the embodied carbon impacts of their projects. So I also have the agenda here just at a high level. I will start with some basics of carbon footprint of buildings. Um, as I mentioned, I will focus on the embodied aspects, but obviously there are significant operational aspects of carbon footprint of buildings as well. So I'll kind of show the overall overview. And I heard that most of the people on this call will probably know some of the basics, so I will try to make that introduction a little bit shorter. But if there are any questions about basics of embodied carbon and LCA, definitely feel free to ask as well. After the intro, I'll go into our EC3 tool, the Embodied Carbon and Construction Calculator, and I'll walk you through the steps of finding data and using the tool to make decisions on your projects. And then I'll switch over to the tallyCAT, which stands for Climate Action Tool, which is our Revit-based plugin for EC3. So I'm actually going to go a little bit backwards from the typical design and construction process. As you can see here, we'll go through procurement first and then through design. The reason is because it does help to have the basics of EC3 knowledge first before we actually go into the Revit interface as well. So that's the reason why it's structured this way. We will have about 10 minutes for Q&A at the end. So if you have questions, please write them down and hold them close, and we'll have some time to address them as well. The learning objectives for today are first just understanding the role of embodied carbon in the whole life carbon of a building, and also learn about the use of the different tools and how you can use them for decision making. So that's these 4 bullet points in a nutshell. As already mentioned, I am part of Building Transparency, which is a nonprofit organization based in Washington State. And again, we focus on providing open access data and tools to address the climate change aspects related to the construction industry. Now, our work would not be possible without the support of all the companies on this slide, both from a financial but also technological and expertise perspective. We work with a lot of these companies to refine the categories in EC3, work on improvements of the building planner, and other aspects of user interface and data in the tool. Now let's go right into the intro and kind of the overview of how everything ties together. So first of all, I know the title of today's talk is about the energy efficiency of building, but as you will notice, I will mostly talk about carbon, and that is the global warming impact category from a life cycle impact perspective. Now, the global warming is dependent on the amount of energy that's used, both during the operational use phase of a building, but also during the production of individual material types. And so there is a direct link, just also depends what type of source of energy you have during those production processes and during the operational aspects of a building. And there's also other environmental impact categories that you will find in whole building life cycle assessments, as well as environmental product declarations. And those can all be important. The main issue with global warming is the criticality of that issue, excuse me, nowadays, and also the fact that it affects us all globally, no matter where those emissions are emitted. A lot of the other impact categories are more localized to where the actual emissions happen. That's why you, for example, see smog around cities. It's directly related to the emissions from transportation, for example. So just a little bit of a level setting at the beginning. Now, why we as Building Transparency focus on the embodied carbon aspect specifically? It's because it is a significant chunk of the global greenhouse gas emissions. When you look at the building-related emissions, you can see that 28% of building-related emissions are from operations and about 11% are related to the production of materials. Now, when we think about operations, we actually have pretty good understanding of how to reduce those operating emissions of buildings. One is, again, switching, changing our electricity grid, also just creating net zero energy buildings that have on-site solar panels and other renewable energy sources. So we have a pretty good understanding of how to actually address the operational aspects. But the building materials and construction piece of the pie here has been kind of neglected for a long time. So we're trying to bring it to the forefront and help people actually address that issue. So that's why we as an organization focus on the embodied carbon. Now, all this is related to life cycle assessment. Now I'm going to go into all the details of LCAs, but essentially you're looking at the substance emissions and energy use throughout all of the life cycle stages of product production, but also buildings as a whole. So, for example, you have the production impacts of individual materials, you have the construction impacts that happen on site in terms of energy use and direct emissions from equipment. You have the operational aspects, and even end of life can have some greenhouse gas impacts related to it, depending on what the end of life scenarios are. Now, this is the full list of life cycle stages that you might see in the life cycle assessment standards. Again, the embodied stages are here at the top. There's many sub-stages essentially in this diagram. And on the operational aspects, you just have the energy and water use. And there are some other operational aspects like, if you're maintaining certain products or components of a building, you may have some direct emissions there as well. But that would all be included in the embodied part of the equation. Now, when we think about different assessment methods and data sources, this is kind of the outline of where some of the data comes from and how specific it actually is to the products or to the building that you actually work on. So usually the production stage is, if you're using environmental product declarations, that's data directly collected from the production facilities, from various manufacturers, across regions, both in North America, in Europe, and other places around the globe. So those are actually measured impacts from the production practices. Then we have the A4 and A5 stages, which if you're earlier in design, those will probably be predictions based on some historical data that we have about transportation and construction practices. But if you get later to the construction stages, you can again actually measure some of these things, and usually that would be within the general contractor's purview. And then we get into the use phase and end of life stages, and currently those are usually predictions and do rely on a lot of assumptions about replacement cycles of individual materials, but also the end of life disposal scenarios. And I wanted to stress the prediction with assumptions because depending on which tool you use for your whole building life cycle assessment, those predictions and assumptions might be slightly different. So you just want to make sure that when you're doing comparisons, you try to use the same tool for the same stage of comparisons that you're working on. Now, when we talk about our tools, I'll start with the EC3 tool. There are two aspects how you can use the tool. First, you can just look for the environmental product declaration data that's in the tool using the find and compare materials section. And when you're doing that, you're only looking at the A1 to A3 stage impacts of those individual materials. Now, there's also the plan and compare buildings feature, and you'll see some of that live a little bit later on. And that plan and compare buildings feature also includes the A4 and A5 stages currently. We have some defaults built in for the transportation impact assessment, but also if you select the product-specific EPD with a specific plant location, we do calculate the direct distance from that plant to the project site. Now, that may not be perfect, but it's kind of a first level of actually more specifying the transportation impacts. And then we also have the construction and installation stage there that will rely on the general contractor or others on the construction site of providing the actual fuel amounts and then linking them to some of the environmental impact data that we have predefined in the tool. Now, we are currently also working on adding some of the additional use stages to the plan and compare buildings feature, as well as the end of life stages. So essentially, EC3 will soon become a whole life carbon assessment tool. And that, as you can see on this slide, also affects the Tally Climate Action tool. Now, we also have the tallyLCA tool, which currently is already a whole building life cycle assessment tool, but it does focus more on the design phases, where you don't need as much specific data about, from specific manufacturers, specific plant locations. It has more of the generic life cycle assessment data in the background of it. So you can't get into as specific of an assessment as you can with EC3. Now, when we look at the typical impacts of a building across the various life cycle stages, typically most of the impacts are in the production stages of materials. There are some exceptions to that rule, but generally you will see kind of this type of diagram on most of your projects. If you're working on a new construction project with the structure and envelope all included in the assessment. Specifically, I would say concrete and steel are usually the largest contributors, and there can be a lot of impacts embedded in the foundations and the structural aspects of a building specifically. The usage replacement can be significant depending on if you're including some of the interiors and what type of interiors you're using, and what the replacement cycles are for the various types of materials. And then, as I mentioned earlier, end of life stage usually is minor from a carbon perspective, but again, depending on the scenarios, there can still be some impacts, especially in the bio-based products, where the products may be, decomposing in a landfill. There can be some emissions related to greenhouse gas emissions, or if you're incinerating it for energy recovery, obviously you're creating a lot of emissions as well. So those are some of the specific examples of end-of-life stage carbon emissions. Now, to break up the presentation a little bit, I do want to pose a question to everyone. Now that you know what the typical impacts of the production of materials are, I worked on this one project years ago when I was at Kieran Timberlake, the architecture firm behind the tallyLCA tool, and we were assessing the benefits of adaptive reuse of their office building. And so my question to everyone here is, knowing that we reused majority of the structural system and the envelope, with the exception of the roof, and then we added some more interior aspects to the building, how much savings do you think we had from a carbon perspective, versus if we went with a new construction project to construct their new office building? So just wild ballpark estimates of how much embodied carbon was avoided by doing the adaptive reuse on this project. Any wild guesses from anyone in the room or online? Give everyone 1 second to type things in the chat. And give you a very wild guess. 3, 2, 1. So we saw about 75% reduction or avoidance of embodied carbon just by reusing all of the structural and envelope systems, most of the envelope systems. So I wanted to, put this slide up here just because this is one of the main design strategies, or it's not really a design strategy, but it is a decision that you can make to avoid a lot of the embodied carbon without really even going into selecting material types and making larger design changes with your building. So this is a very critical design strategy that you can use to reduce the embodied carbon of buildings. Okay, now let's take a broader look at some of the tools that we have and how they actually fit into the design and construction process. So I'll start with actually a tool that's not ours, but it is also an access tool created by EHDD Architecture in San Francisco. It's called the EPIC tool, and this tool allows you to enter basic information about a building project like the use type, square footage, etc., and project location, and it gives you the typical impacts of a project of that size and use type. And it gives you the carbon footprint, both from an embodied perspective and operational perspective. This is kind of the first way that you can start understanding of what the typical impacts of a building like yours can be without having all the detailed material quantities. So I do want to stress that tool as well. Then we get into some of our tools. So that's tallyLCA and tallyCAT. Those are most useful during the design phases, schematic design and construction documentation. And those allow you to compare different types of systems, so envelope systems, structural systems, etc. But also later on, in some cases, they can help you with comparing individual product types. So even if you have different types of carpets, for example, you can do some of those comparisons there as well. And the other tool that's here is the Athena Impact Estimator. That's another open access tool, not created by us, but I do want to also mention it because it's a very useful tool, especially earlier in design phases. It has some really, really nice features of helping you estimate quantities. Then we get into the construction phases, and this is where EC3 really was first brought into the picture and was designed to help during the construction stages. It allows you to compare very specific product types from very specific manufacturers and locations, and show you the differences and impacts based on the environmental product declaration data that's out there. Now, there's many other tools. We obviously can't go through all of them, but I would just say, try some of these tools out and use the one that fits your particular workflow the best, and just make sure that if you are making comparisons and designs or product choices, that you do try and stick to a single tool. Again, there can be some differences in the assumptions and background data sources across some of these tools. Okay, now let's go into the actual demo of both EC3 and tallyLCA. I think we have about maybe 25 minutes for all of this, which should be plenty of time. Going to go into I need to find my browser, and we'll start going through the walkthrough. So first of all, if you don't have an EC3 account yet, you can go into buildingtransparency.org and click on the register free button. Again, it's fully free. I do recommend that you use your professional email accounts and fill out the employer and and fields on the registration page, it will give you the professional account in EC3, which has a little bit more functionality than just the basic private account that you would use if you signed up with something like a Gmail account. Once you register and you open EC3, you will actually land on our landing page, which is this. And this landing page shows you the overall overview of the type of data that we have within the tool. Now, so you can see here how many EPDs we have across the various regions around the globe. We are not just a North American based tool. We are continuously adding data in Europe and other places as well. You can also see used to have statistics on right here. There's these arrows. We have statistics on the different product categories that are represented in EC3 as well. So for example, we have a lot of EPDs in the concrete category. This is because the concrete industry has actually embraced digital creation of EPDs. So we have about 130,000 EPD data points for just concretes. Slightly different for some of the others like finishes. We have 7,000 EPD data points there. Asphalt, thermal moisture protection, that includes insulations, electrical, steel, etc. So we do have a whole gamut of product categories that you can find in EC3. Now let's try actually finding some specific EPDs next. So the user interface here at the top, you have your profile. You have some profile settings there as well. You have your organization, which also has some settings. So if you want to change some of those, you can simply click on the logo of your organization. And there are some additional settings like the measurement units up in the top right corner. You can switch quickly between SI and USA units. If you are a developer, you would like more of a programmatic access to our database. We also have API and integration section here, which allows you to use things like Python and other programming languages to actually access our database. And there are some other resources for you as well. But let's get to the main point of today's talk and also the main feature of our tool, and that's finding and comparing specific material types. So we'll go into find and compare materials here in the top left corner. And what you will see is that we have a long list of material categories that you can choose from. This is loosely structured by the master format divisions, but you will see that we do have some differences in this list. You can also open up some of the subcategories. And in order to be able to search for EPDs in a particular category, you simply click on that category, a subcategory, and go to the next step, which is looking at the EPDs. Now on this page, you can do two things. So you can either specify additional performance characteristics that you want to search by. So for example, the compressive strength. And by the way, these fields understand different types of units as well. So you can type in 4,000 PSI or 20 MPa, and the tool will understand exactly what you mean. Once you fill in some of the performance specification filters in here, you might have to scroll a little bit lower, but you can now search for EPDs that fit that particular performance criteria or your search filters. And once the tool actually finds all of the EPDs, you'll get a couple additional things. First of all, you will get this box plot diagram on the right side. That shows you the ranges of carbon footprint per unit of a concrete of 4,000 PSI. And this is all based on the EPD data that we have. So for example, what this is saying is that the lower carbon products in this category are typically around 285 kilograms of CO2 equivalent per meter cubed of concrete. And some of the higher impact concrete mixes are up to 440 kilograms of CO2 equivalent per meter cubed of concrete. Now there are some outliers both at the bottom at the top here, but typically if you're setting thresholds or targets for your projects, you would use some of these typical values in the achievable and conservative range. You also see on this diagram that we do have the 2021 CLF baseline here right now. We could change that using the settings button. You can select from the 2019 CLF baseline, 2023 CLF baseline, or you can select custom baseline as well. Actually, that feature is coming soon. But essentially, the idea is that you can now better understand of what the typical ranges of impacts of this type of material may be. And that may also differ for, different compressive strengths and different types of characteristics of that material. Now, when we scroll to the bottom, again, you can see the statistics, but this time in terms of the actual values. And you can also see how many EPDs are actually represented in that statistic. So we have 20,000 product-specific EPDs. Now, if you do want to see industry-wide EPDs, you would have to open up that specific section. And you can see that we have industry-wide EPDs from Europe and from North America here, both Canada and United States. But I think the main feature of EC3 is helping you find specific product types and specific concrete mixes that you may actually be using on your particular project. Again, this is very useful later in the construction stages when you're trying to track the actual impacts of your particular project. So what you see here in this table is the individual EPD data points. Now, obviously, we can't look at all 20,000 all at once, so you might have to scroll through some of the pages here. But you can also search by specific product names. So if we wanted to, actually, let me see. If we wanted to see products just from Cemex concrete, for example, you can type it in the manufacturer. Take a second, and then we can see all of the mixes from various plant locations from Cemex. We could go a step further and look at specific plants as well, but you kind of get the idea of how to access the information. Here you can also open up the actual digital EPD page by clicking on the open button. And from there, you can also download the original PDF document most of the time. This is actually a digitally transferred EPD, so it does not have the PDF document attached here, but in most other cases, you will be able to download the original PDF document. And this page shows you the specific additional information that you might see on a PDF version of an EPD, that you might be used to seeing when someone gives it to you, for example, for lead purposes. Now let's go back to the list of individual products. Now, how can you actually understand the impacts of one product versus another? Well, you can see the global warming potential value here in this column, but you can also click on the compare button and select individual product types. Scroll to the top of the page and you will see them lined up side by side. And you can still also see the general category statistics, so you can see how the individual mix designs compare to the rest of the category as well, but also to each other. So this is the basic way of really searching for material types. I think let's switch a little bit and go into the plan and compare buildings feature and see how you would actually use this when you're working on an actual project. So in the plan and compare buildings feature, you can create a new building project by clicking this plus building project button. We'll start from a blank project in this case, but there are other opportunities of importing material quantities from other tools. And then you should be entering some of the basic information about the project. One of the critical pieces of information is definitely the project location. So I'm in Oakland, California, so I'll select that location. Now I can actually use the project location to search for environmental product declarations or products that are manufactured within a certain radius of my project site. So that's one of the actually useful pieces of information to fill out here. The rest of this is mostly for bookkeeping, or if you're trying to do benchmarking within your firm, it is definitely a good practice to fill out some of the project classification features and other essentially metadata about your project. I'll scroll through all of this. The floor area above grade and below grade, those are also critical pieces of information, because if you're doing a comparison across building projects or even designs, we do that comparison on a per unit area basis, and I'll show you an example of that a little bit later. but it is important to fill out the floor area above grade and below grade so that we can do the calculation of impact per unit area of a building. It's kind of, it's a similar idea as the EUI, the energy use intensity. Now, finally, at the very bottom of this page, we have the actual material quantity table. And in my case, because I started with a blank project, you can see that these are just placeholders here with generic names of elements and quantities of one. Now you can overwrite these. You can, let's say, rename this to concrete footing. Then you would click on the category button, and that brings you to the same interface as we just saw earlier, when we were looking at generally for specific EPDs in a particular category. So we'll go into concrete ready mix again, click on EPDs here, and we can specify additional performance characteristics, but you also don't have to. We could simply click on use this collection, and that will apply that ready mix category. And then now we can actually modify the amount of that ready mix. So now we have 1,000 cubic meters of ready mix. And if I actually had 1,000 cubic yards instead, simply change that unit, and you will see that the tool understands the different units as well. So when you're working on a project like this, you essentially need to fill out this whole table. I do want to show you an example of a fully built out project. So go back into My Buildings, and we'll look at this BT residential design. Now this is a fully built out building where if I go to the bottom of the page, you will see that most of my material quantities are already defined. I have different foundations, piles, rebar elements, columns. I even have interior and exterior enclosure elements here. And you can see I have different categories and specification filters filled out as well. Now, once you have everything filled out like this, you can go into the charts section. Also, you can see that we already have the embodied carbon intensity already filled out here at the top. So we have 52 kilograms of CO2 equivalent per square foot. And we can look at some additional visualizations like which product categories are contributing to the whole project as a whole. So we'll look at this GWP Sankey diagram. Now, this may be overwhelming for anyone that hasn't seen one of these before, but I'll try to simply simplify it in terms of my explanation. On the right side, you have the overall impact of the project. So that if you hover over it, we have 5.42 million kilograms of CO2 equivalent. And the solid bar chart versus the hashed bar chart, the difference is, again, using the conservative embodied carbon estimates versus some of the achievable values that we saw on the earlier box plot diagram. Now, if we move to the left, from the right to the left, those are how much the individual systems within that building are contributing to the overall impact of that project. So for example, you can see that interiors and shell are the two largest contributors. There's not as much embodied carbon in the substructure, and that's just specific to this particular project. If you go further to the left, we can then see how much embodied carbon there is in the columns, how much there is in the slab on deck. And again, what your opportunity for actually selecting specific product types that help you lower the carbon footprint of your project, what that opportunity window is in there. If we get all the way to the left, then you can see the individual material types. So you see rebar steel, ready mix concrete, decking steel, etc. So you get the idea of what this diagram is telling you. Now, in this particular case, you can see that the ready mix, it might be a little bit too small to see, but there is a little bit of a S line going through the ready mix category. Made it too small. Okay, hopefully you can see this, but there's a S line going through the ready mix category. That means that I selected a specific product-specific EPD for my ready mix concrete, and that is showing me exactly where that realized global warming potential value for that concrete mix lies when we look at, again, the category statistics from earlier. So in this case, I actually made a conscious choice of a lower carbon concrete mix. Now let's close this. There are additional reports that you can export into Excel, and then you can view, or you can create your own visualizations from the Excel report. The Excel report has all of the information that you see in this table here, plus some additional columns, including some of the CLF baselines, all of the different conservative, achievable, and realized values, etc. I think the last thing to point out here, or maybe maybe two last things, is that if you make a specific product selection, that product selection will then show up in this table as well. And if you click on the link for that product specific EPD, it takes you to that particular EPD and you can look at all of the details of that product. The second thing that I wanted to point out here, that in some cases, there are elements where maybe you don't have the actual material quantity in the unit that we need it, or that EPDs actually use. And that's, for example, let's say these metal studs, EPDs report impacts per unit of mass. But if you're a designer and you're working on a wall system, you might not know immediately what the mass of a metal stud is in your wall system. You will know the gauge and kind of the profile of your stud, and the spacing of the studs. And so in cases like that, we do have helper calculators that you can use. You simply click on the quantity the quantity field. You can select some of the predefined calculators here, and then define the profile of a stud, including the gauges. You can also type in exactly which stud you're working with. So for example, if I have a 3-inch stud, you can type that in. If it's in our lookup table, you will find it. If it isn't, it will not show up. So let's say 2.5-inch 30 mil stud, spaced at 16 inches on center. And then you can see, based on the wall length and wall height, we have 272 kilograms of metal stud in this particular wall system. So that's another nice feature of the building planner that you can use. Now with that, we have about 5 minutes, which might seem like not a lot for showing you tallyCAT, but luckily it's actually just EC3 running inside of a Revit window. So let me switch my screens again. I will open up my Revit interface. And I already downloaded tallyCAT before, so I can find it in the add-ins section. If you don't have it, again, you can find it on buildingtransparency.org. And I can share the link at the end of this session as well. Once you download the plugin, it's going to be in the add-in section. You will have to log in with your EC3 account, and then you will have to take the first step on using the tool, and that's creating a tallyCAT view in Revit. So I click on that button. What it's essentially doing, it's creating a 3D view inside of Revit with the specific selection of product and material categories that we can actually get the material quantities from that Revit model. So we don't include all of the different categories that you might see in Revit. We only use the selected one that we understand how to use the material takeoffs from Revit. And that includes these 13 categories: ceilings, columns, curtain panels. Again, it mostly focuses on structure, envelope, and some of the main interior components. There are some additional settings that you can modify here, but let's go to the next step, and that is exporting the model into EC3. So I'll click on the export button, and this will take a little bit of a time. The tool is collecting the dimensional information from the Revit model right now. And because I had the automatic recognition of material types checked off, it will also try to recognize what types of materials you have identified in your Revit model and link them to specific product categories inside of EC3. So that's what the tool is doing right now. While this is actually loading, the idea is that for selecting your scope of the export, everything is visually connected to what you can see in this particular view. So if you want to exclude particular Revit categories, you can simply hide them from this view. If you want to exclude specific elements of the Revit model from your assessment, you can also hide individual elements. It doesn't have to be that you hide an entire category. So whatever you see on this particular in this particular view is what is going to be exported into EC3. And tallyCAT is now at its last step, saving the EC3 project. Now it's prompting me to save the Revit model, and the reason is because we do add some additional information to the Revit model itself in extensible storage, so that the information does get transferred across. Let's say if you're working on a large team and multiple people are accessing that Revit model, all of that embodied carbon information actually gets stored within the Revit model itself. Now we'll save this project. And we will open up the EC3 window in a second. Revit is still thinking here. Okay, so now everything is processed. We'll synchronize this to central. And now we can open the project in EC3. So I'll click this button in a second. You can also see a full report of if the tool has had any challenges with recognizing some of the elements. But anything that's not errored or ignored is okay. If you have warnings, that's fine. Sometimes we just give you warnings, just to make sure that if there are some, there may be some elements that may be a little bit harder to get the dimensions from. Okay, I clicked on the button that opens a new window, which opens up my other screen. So I'll drag it over here. All right, and now this is a Revit window that is running the EC3 tool inside of it. So I'll close this menu so you can see it a little bit better. It's a little bit slow right now, but here it is. Okay, so we have our new EC3 project, which was based on this Revit file. We take the address from the Revit file itself, and we do take the floor area from the Revit file. I will say that it is kind of hard to get the floor area from the Revit file sometimes, so please double check that that value is correct. And then after that, the main part of what we need to see here is again the material quantity table at the bottom of the list, bottom of the screen. Now you can see that we have all of the Revit categories listed here, all of the ones that we had selected during the export. And if I open the actual list of categories, you will see the individual Revit families listed here as well. And let's take a look at an example wall system. For example, let's do this basic interior partition. If I reveal that, you will see that we have the individual layers of that wall family as well. So you can see the type X gypsum, metal stud layer, and additional layers of gypsum wallboard. There may be other layers, obviously, in some of the other categories, but the idea is that we get all of the material quantities from the Revit project. And we also try and recognize what exactly these names of the materials are. And you can see that in this case, it predefined all of the EC3 categories that are most likely related to these particular Revit layers. Now, we don't get this right all the time, so I definitely recommend going through the entire project at least once and refining some of the category assignments that EC3 has done by itself. And also, as I mentioned earlier, with some of the material quantities, as you know, if you're using Revit, you don't always model all of the intricacies of a wall system in its full detail as it is actually put together. Again, I'll use metal stud as the same example as earlier on. Metal studs are simply a solid layer within the Revit model. You will have to add some additional information of what that metal stud layer actually looks like in terms of the profile and metal stud spacing, or you will get some ridiculously high numbers on the material quantities. So you can see that, for example, here, 7.91 thousand This is probably kilograms of metal stud layer. I think that's before the actual calculation and consideration of specific stud profiles. You can see that these two fields are empty right now. So I will have to go and actually refine what the metal stud profile is, and again, add the spacing in there as well. And after I do that adjustment, I will get a more accurate material quantity takeoff than what I'd had before. This is a little bit hard to select. I think should be it. All right, here we go. So we did actually have some defaults built in before, so it's not actually that much of a difference, which is good. But I will just, stress, please go through the model one more time yourself and make sure that all of the material quantities do make sense. Now, after this is really all there is to tallyCAT. You can do some visualizations, you can select elements and sort of isolate them or view them in the model itself. So there is a direct connection between the Revit model and the EC3 interface. In this case, it can help you with essentially quality assuring your model and some of the material quantities and understanding where they're placed within the model itself. But otherwise, this is all there is to really tallyCAT and EC3. There are some additional features that you can use, but these are some of the basics to get started with the tool. So we have about 7 minutes. Let me show you one more thing, and that is how you actually make some of the larger design decision comparisons in EC3. It's one of the things I haven't touched on. I'll go back into EC3 interface within my Chrome browser, and I'll go into EC3. Plan and compare buildings, my buildings. I have a couple of projects that I've already designed here, right? So I have these two demo designs, design 1 and design 2. Now let's say you build up your entire project and then you make some material swaps or material choices within each of those projects. In order to compare them, you simply select those projects, click on the compare projects button, and then you have additional visualizations and see what the actual embodied carbon comparison is. So for example, we can click on comparison bar chart, and in this case, we will see what the kilograms of CO2 equivalent per meter squared is, and you also see the range of impacts before selecting product-specific EPDs on either of those designs. So this was the last thing that I wanted to point out. I showed you how to compare individual product types, but you can also compare individual projects as a whole. And with that, I'll wrap it up and we'll open up to Q&A.
Thank you very, very much. It looks like the room is unmuted, and then anybody else online, you're welcome to put it in the chat or unmute yourself. But thank you so much, Vaclav. Really appreciate it. Looks like there's a question from Liam Buckley.
How does EC3 compare against one-click LCA? Does it have any baselines available for color green? So how does EC3 compare against one-click LCA? That's a very open-ended question. I will say, so EC3 currently, there are multiple differences, but currently EC3 is solely run on environmental product declarations. It doesn't have any generic background data, although we are working on adding some of that data. It's also focused on the upfront carbon at the moment, but as I mentioned, we are adding additional life cycle stages. Now, one-click LCA does have some of the same EPD data as EC3 has. We actually have a partnership now so that we get one-click generated EPDs directly in EC3. And they also have access to our database as well. So there is some overlap on the data that's used behind both tools. Obviously, there's many other differences in the features. I know one-click LCA specifically has certain features for for specific certification systems, especially in Europe and other places around the globe, where it really tries to streamline the process of making, achieving certain certifications and some of the criteria in those certifications. I think EC3 is more kind of user-focused, open-ended, and it gives you more customizations and more responsibility in setting up some of the projects for something like certification reporting. And does it have any baselines available for color green? I don't think we have anything for color green yet, because color green is, to my understanding, focused on the whole building impacts. We do have some baselines built in for each of the categories, and also some of the filters, like the compliance filters here, have some of the state-related procurement requirements that are popping up across the country. But again, that's more on the product category level. It's not necessarily on the whole building assessment level, which is what color green is. So I hope that helps a little bit. Okay, another question. Any future consideration for integration within Revit instead of working between the two programs? I guess right now the tool is, integrated within Revit. I know the user interface makes it sound like makes it seem like you're switching between the two tools, but they really are integrated. So I guess that would be more of a maybe feedback for us in terms of what you would like to change around the user interface that would make you feel like you're a little bit more connected to the model. But generally, it is at least trying to be as integrated as possible. Not sure if that's the right answer, but I hope that makes sense. Any other
I have a question. Yes. Does EC3 has a requirement for manufacturing, like EPD, certain format of EPDs can get uploaded, or does the data get normalized after they're like? Is there a certain way to be able to compare these available EPDs on EC3?
So so you can upload any EPD that has already been verified and published by a program operator. We don't do verification or publishing ourselves. We're just taking the data that's out there. And there are obviously different rules and product category rules that each EC3 complies with. We track all of that information, so it is available there, but we don't necessarily curate the type of EPDs or how you can make comparisons across EPDs.
So they do not share their like common system boundary or like certain methodology, or for example, for the bio-based material, do they treat biogenic carbon the same, or is it something used?
Yeah, good question. So specifically on bio-based materials, we do actually do post-processing of some of the data based on the bio-based content of a particular product. And we do separate out the fossil-based GWP from the biogenic-based GWP. So we do normalize some of the data specifically in the wood categories from that perspective. In terms of different life cycle stages, again, we do take results for A1 to A3 stages and then the other stages separately. And so you're always comparing, essentially a line set of life cycle stages. And also you can't really do comparisons across product types easily unless you do it at the project level. And that's also to kind of make sure that you are comparing more like-to-like materials that have less likelihood of having actual methodological changes in any of the background LCAs. So those are some of the aspects that we do. to normalize the data. The last one is maybe related to the declared unit. Again, we have essentially an authoritative declared unit in each of these categories, and we do make sure that it doesn't really matter if a particular set of impacts is reported per square foot or 1,000 square feet or a meter squared. We do all of the conversions for you in the background. So anything you see here, there is a level of normalization that goes on to make sure that the data is comparable.
Great, thank you.
Any other questions?
So one more small question. Or are you thinking about integrating some kind of filters in like developing the EC3 later for filtering certain system boundaries, for example, or filtering different methodology? So the user can just pick those EPDs that are following certain rules.
So it depends exactly what type of rules I think you would like to filter by. There's a feature, so you can filter by specific product category rules. We already track that information. If you're looking for filtering by, let's say, the different allocation methods used within these PCRs, like it's a little bit trickier because those allocation rules, may change in a particular version of a particular PCR, and we don't go as deep as actually tracking all of the PCR parameters around methodology. So it's essentially a step further than what we already take in terms of digitizing EPDs and PCRs currently. Now, if you do have a particular product category rule in mind that all of your EPDs or all of your data needs to comply with, then you can select that specific PCR here and search just for EPDs that follow that PCR. You can also do multiple selection here. So if you have multiple PCRs, you can also do a search for EPDs that follow those particular PCRs. Does that help or answer the question?
Yes, it was very clear. Thank you so much.
Yeah. All right.
Thank you so much for your time and presentation, and yeah, for sharing about EC3. And it's a really tremendous tool. As you mentioned, we're trying to clamp down on operational energy, and yet kind of the Wild West right now is in the embodied energy that's going into the materials. And so this was a topic that was requested by a lot of our BSUG attendees. So we appreciate your time today.
Great. Yeah, it's great to be here. If you have any follow-up questions, feel free to reach out to me as well. Or you can also use the report box and feedback button if you're inside of EC3. But yeah, it was great to be here. Thank you.
Thank you.
All right. And for those in the room, Barnaz, if you want to let us know about the next BSUG, and if you also wouldn't mind filling out the polls that are in front of you. Online folks already had that, but for those in the room, we have some paper copies.
Yes, thank you everyone for attending. Then our next BSUG session needs some confirming some details. I will share it with you all with our LinkedIn page and email. That was all.
Great. Thank you all.
Thanks, everyone.